Okay, so question 3 is a probability question. We are looking at a histogram here, and we're going to be asked to calculate some observations based on the histogram. So, we are asked to, first of all, complete the following table of cumulative probability. Now, watch this word cumulative, because some people will mess this up and consider the wrong probability. The word cumulative means the total probability up to that point in time, rather than the individual probability between the intervals. So if we have a look at this first part, we're asked to complete the table of values. The probability that the random variable is going to be less than 5, well, that is all of the area over here on our sheet. And we see that there is actually 0 probability for that, so the answer for that is going to be 0. Similarly, for 15, we have got all of the data in this area here, and we know that that is going to be 4 divided by the total frequency that we see at the top, which we see as 20 up here. So 4 divided by 20, that is the same thing as 1/5 or 0.2. Now, below 25, I'm going to rewrite that for simplicity. Now below 25, that is all of the data in this area, plus all of the data in here. So we've got 4 plus 8 are observations there, which is 12 out of 20, which is the same thing as saying the same as 6 out of 10 or 0.6. Now below 35, we've got all of this data, all of this data, and all of this data. So in total, that's 12 plus 6 observations, or 18 observations. Now the probability of 18 observations is going to be 18 over 20, which is the same thing as 0.9. Now last one is this 45. Now less than 45, that is all our data across the entire sample. So we're going to be able to say that that is 1. Okay, so now we ask to calculate the probability that P is greater than or equal to 35. So the probability that P is greater than or equal to 35 is going to be all of this data over here. Now, we don't have that exactly, but we do have this table right here. We know that the probability of it being less than 35 is 0.9. Therefore, the probability of it greater than 35 is going to be 1 minus 0.9, which is the same as 0.1. We are asked to estimate the probability that it's greater than 20. So we see that 20 is this point here. Now we can assume, based on the accuracy of the data, that is about half of the observations. So we would be left with 4 observations here, plus half of 8, which is another 4 observations. So that probability would be 8 out of 20. Half of 4 out of 20. No, sorry, 8 out of 20. Which would be 8 out of 20, which is the same as 0.4. Estimate the expected value. So for the expected value, we know that the expected value is the same thing as taking a weighted average of all these things. So we're going to use these point estimates here. We're going to add them up and multiply by the number of observations. So that means that we've got 10 times, and we've got, I think it was 4, yeah, 4 out of 20, plus 20 times 8 out of 20, plus, what was the next one, 30 times 6 out of 20, and the last one was 40 times 2 out of 20. Total that up, 10 times 4 out of 20, 40 out of 20, that's 2. 20 times 8 divided by 20, that's the same as 8. 30 times 6 divided by 20, that's 9. 40 times 2 divided by 20, that is the same as 4. Add those all up, we've got 10 plus 9, 19, 23. Okay, now we've got this. To increase the generation capacity of its solar farms, so Colva decides to upgrade all its solar panels with the latest technology. A new variable denotes the generation capacity of randomly selected solar farm. The variables W and Y are related by some constant here, A. So basically that means whatever W is, we multiply that by some constant value A, and that gives us Y. So, given that W and Y have variances of var W equals 81 and var Y equals 384, determine the expected value e to the Y. Okay, so the problem with finding the expected value is unfortunately we do not have this A, so it's a good idea to figure out how we come across this A first. Now we know that if we have two variables x and y, and we have y equals a times x, then we can relate them with the formula var of y equals a squared times the var of x. So in this case, we have var of y, var of y equals a squared times the var of w. Now, we know that the var of y is 324. We know that the var of w is 81. So all we need to do is do 324 divided by 81. A squared, and that is going to give us 4 equals a squared equals, a equals 2. Right, we reject the negative value. So now that we know that a equals 2, we know by the linearity of expectancies, e of a times x equals a times e of x. So by this equation, we know that e of a of w equals y equals a times e of w. So we must have y equals a is 2 times the e of w found up here 23 equals 46.
Thank you for watching. My name is Henry, part of a team at Elucidate, a non-profit organisation that helps young people succeed at school. If you would like to see more chemistry videos, click up here. If you would like to learn more about us or support us, click down here.